So in this first demonstration, what we're going to do is simulate what happens in your cars every day. First of all, we have a bottle, and that bottle has a cork in it. I know you can't see it, but there are two nails that are embedded in the bottle. The nails are close to touching, but not quite touching. Here's the cork, and the cork fits snugly, but not too tightly, in the mouth of the bottle. With my goggles on, since we're going to be dealing with ethanol, which could damage my eyes if I got enough of it in my eyes, I'm going to pour just a little bit. Just so that I can see some puddling inside the bottle. And now I'm going to cork it, and I'm going to swirl that puddle of alcohol throughout the bottle. So here I am swirling, 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 swirling. This is called a Tesla coil. It will play the part of a spark plug in your car, and its job is to produce an electric arc. Let me turn off the lights so that you can see it. So it's going to produce the electric arc that is necessary to make the reaction go. So let me set it up. So what I'm going to do now is I am going to get the Tesla coil close to one of the nails. We'll see what happens. So, what exactly is going on here? You will be responsible for many of the details of this demonstration. First of all, what were we dealing with? We were dealing with an alcohol. An alcohol is made up of carbons and hydrogens. Therefore, it is called a hydrocarbon. So this is a hydrocarbon. The hydrocarbon was reacting with oxygen. Oxygen gas, to be exact. Okay? We call the compounds or elements that react, we call them reactants. Reactants. So when this hydrocarbon and the oxygen reacted together, when they interacted, when they broke each other apart, and they're going to reform new things, we call those new things products. Products. So what products were produced? Carbon dioxide, gas, and water gas, which we call water vapor. So these are the products of the reaction. In chemistry, we're going to learn how to create a shorthand for this. And we create a shorthand for this by using their chemical formulas. The hydrocarbon that we used was ethanol, which is drinking alcohol, though I wouldn't drink the alcohol in the chemistry lab because it has been denatured. What does it mean to be denatured? What it means is that they've added another hydrocarbon to it to make it poisonous to you. Now, why would they make it poisonous? Well, it's drinking alcohol. So if they do not make it poisonous, then you can actually drink it. And if you can drink it, then it requires it to be taxed. So how do we get away with not having to pay taxes on alcohol? Well, we allow the chemical companies to denature it, to make it undrinkable. There are things in your life that are denatured alcohol, such as perfumes and colognes contain denatured alcohol. What does that mean? That means that conceivably you could drink it if it had not been denatured. So they add other chemicals to it to make sure that if you do drink it, you will regret the day that you were born. So if you become an alcoholic, God forbid, you become an alcoholic in the future, and you are so desperate for alcohol that you look at a bottle that says that it has alcohol in it, and you're tempted to drink it, don't drink it, especially if it says denatured alcohol. You will spend some time in the bathroom vomiting. So this is ethanol, but it is denatured ethanol. And it's going to react with oxygen to produce carbon dioxide and water. Now, you may be familiar with some of these symbols because you've covered them before in middle school. This is called a combustion reaction, and it's one of the 5 types of reactions that we're going to cover this year. So you're getting the very first one in the very first demonstration. And it is the key to making your car go. How? Okay, so we have the bottle. We place a little bit of alcohol down the bottom of the bottle. We have 2 nails. Why did I swirl it? Well, remember what a combustion reaction involves. It involves a hydrocarbon gas. That's the key. This is a liquid. So why did I swirl it? Well, what did I do by swirling it? I increased the surface area. Anything I write down, I would write down in your notes. I increased the surface area of the alcohol. So now the alcohol is coating the inner surface of the bottle. Why is that important? Because once again, I need it to be hydrocarbon gas. I need that liquid to evaporate into a gas. So what am I going to do? I'm going to spread it out. Why is it important to spread it out? Because evaporation occurs at the surface. So the more surface I have, the greater the evaporation. So as it begins to coat the inside of that bottle, I start gathering more and more alcohol vapors in there. Now the alcohol vapors are combining with the oxygen gas. Think of it as you're at a dance and you see a really, really pretty girl and she's dancing by herself, guys. And you're against the wall and you're seeing there and she is dancing and she's looking at you and she's pointing to you and asking you through her gestures to come and join her. Well, nothing's going on and nothing's going to happen until you get off that wall and go into the dance floor and join her. Imagine Oxygen is that really pretty girl who wants you to come and dance with her. You, as alcohol liquid, you are standing against the wall. Nothing's going to happen. As long as you are against the wall, that girl will continue to dance by herself. So what has to happen? A friend needs to come over and push you into the dance floor, and then the dancing can occur. think of evaporation as that friend pushing you into the dance floor. So now we have oxygen, which is that girl, and we have alcohol, which is you, and nothing's going on. You guys are just kind of staring at each other, and you don't know how to get started. You barely even know each other. She thought you were good looking, you thought she was good looking. What are you going to do? That is what the Tesla coil is all about. The Tesla coil is going to initiate a spark. Here's my terrible Tesla coil. You want good drawings? Go see Miss Schrock. So as I got it near to the nail, the Tesla coil zapped the nail. So you have an electric arc, you have a charge of electricity, of electrons going from the Tesla coil to the nail. Why weren't these touching? Because if they were touching, then you would never see the electric arc go across the air here. So by not touching, that caused the electricity to jump from one nail to the other. What does the electricity do? It kind of gives it that spark, that special moment that allows the girl and the guy to say, you know, let's just dance, and get them to begin to dance. All right? So, what do we call this in chemistry? We call it the activation energy. It is the energy required to get a couple dancing, to get a reaction going, to get two reactants reacting. It is the minimal amount of energy needed to get the reaction going. In this case, it was a spark. All right, well, lots of relationships begin with just one dance on a dance floor. And in our analogy here, what we have is a relationship that is occurring between alcohol and our the drinking alcohol and the oxygen. And once that reaction occurs, then amazing things happen. They will actually disassemble themselves like Legos and reassemble themselves into different things. So what began is no longer. What is now are new people, new things. So when this happened, a reaction occurred. Sometimes reactions give off energy because the new Legos don't need as much energy as the original Legos. Sometimes it takes in energy. In this case, obviously, energy was released out. Echo is the Greek word for out. Thermos is the Greek word for heat. So heat went out. Well, what happened when heat went out? Okay, so let's get back to our bottle. We have the reactants. We have oxygen. What else do we have? Well, you may not realize this, but when you breathe in, you're breathing in mostly nitrogen gas. We were breathing in oxygen gas, mostly oxygen gas, we would be in big trouble. So air is let's just roughly 80% nitrogen, 20% oxygen. So when you breathe in mostly nitrogen. When you breathe out mostly nitrogen. Think about it. You do not use up that nitrogen. Okay? So what happens is what you breathe out is still mostly nitrogen, mostly oxygen is the second part, and there might be a little bit of carbon dioxide. That's why CPR works. Okay, think about it. You're trying to resuscitate somebody. You're trying to get their lungs to work. If you were breathing out carbon dioxide, what would you do to them when you breathe into their lungs? You would be poisoning them. No, no. Even though it is your exhaust, what you are breathing out is still going to be the oxygen that that person desperately needs. So that's why CPR works. You breathe in, mostly nitrogen and oxygen. You breathe out, mostly nitrogen and oxygen. So there is going to be a ton of nitrogen in here. So when energy is released, all these molecules start moving faster. And they will move in every conceivable direction. If they hit the side of the container, when they hit the side of the container, they exert a little bit of force. We call that pressure. It's a little push, teeny tiny little push. So the more molecules we have in here, which we have a ton of molecules in here, the more they can push against the side of the container. The faster they're moving, and they move faster from a gain of energy, then the more they collide, and the more they collide, the more pressure they can exert. Now, this bottle is pretty tough. That's why I used it. So it's going to have to require an enormous amount of energy for these molecules to burst open the bottle. But there is a weak spot in that bottle, and that is that cork. That cork is shoved into that bottle opening, but it's not very tight, so it is the weak spot. So as more and more of these molecules are hitting that cork, there comes a point in which that cork can't withstand that pressure, and it is going to be pushed away. And that's what happened. That's why the cork flew across the room, because of the pressure, the force of the air molecules who are super hot, pushing it away. Okay, so I want you to remember pressure. And I want you to remember that hotter molecules move faster, which means the inverse is also correct. Cooler molecules move slower. And so what would happen if we were to do the opposite? What would happen if we were to put an ice jacket around this bottle? Would the cork fly across the room? No. These molecules would move slower, they would collide less, there would be less pressure in the bottle. So what does this have to do with your car? Well, your car has anywhere from 4 to 8 of these bottles inside the engine. Well, they're not really bottles. We call them cylinders. So your car is either a 4, a 6, or an 8 cylinder. These cylinders have a piston inside. There's also a nozzle that will deliver fuel. We call it a fuel injector. And there is a nozzle that will deliver air. Okay, so what happens? Imagine that it's a bottle. The air injector is going to inject oxygen and nitrogen in here. Remember that nitrogen is not going to do anything, but it can push, and it does. And the fuel is going to inject not ethanol, though a lot, quite a bit. Some of our fuel does have oxygen, ethanol in it. As you can tell, every time you fuel up your car, you'll see that it's what? 15%, 10% ethanol. So ethanol can be used as a fuel, but basically the other thing we use is octane. That's why it has an octane rating. So as you can tell, carbon, this is an H, carbon, hydrogen. Let me erase that. That's sloppy. Carbon, hydrogen, that's a hydrocarbon. So now you have a hydrocarbon in here. All right, it's sprayed, so it's sprayed as a gas, so it's already in the gaseous form. You don't have to entice it out of the dance floor by swirling it. So everything's there, everything is ready. Now what do you need? You need the spark plug to do its thing. The spark plug is going to zap, create a zap. The octane and the oxygen react. It's going to push down on this piston. By pushing down on the piston, you cause, and this is the part I'm not really familiar with, you cause arms to move, which causes your crankshaft to rotate by a quarter, which of course your crankshaft is then connected to your wheels somehow. This is the engineering part. And of course the crankshaft is going to be connected to the other cylinder, which is in pair. So when this one pushes down, it causes this piston to push up. Then you get spray, spray, spark, explosion. This piston is pushed down, which causes this piston to be pushed up, and it continues the process over and over and over again. So what we saw with this ethanol cannon happens in your cars literally thousands of times a minute, and it is what allows your wheels to rotate and for you to drive down the street. So the spark plug is, in our demonstration, was played by a Tesla coil. The air was already in the bottle. The fuel injector, that's when I supplied alcohol in the form of a liquid. Because it is an injector, it automatically goes in as a gas, and you don't have to swirl the cylinder in order for it to become a gas. So you have the fuel plus oxygen. What forms? Carbon dioxide and water, and there is a way for those to escape, and that goes out your tailpipe in the form of gases. So when you during the winter time, you're behind a car and it's really, really cold and you see smoke coming out of the tailpipe, guess what that is? That's not smoke, that's water vapor. Why is there water vapor coming out of your tailpipe? That's the water vapor that is made from this reaction. That's it.